Hello and welcome. I'm Poornima Nayar, and I will be talking about how we can make use of the GraphQL endpoint in Umbraco Hardcore and use that to present the content from Hardcore in a little Blazor app. An intro about myself. I'm a freelance .NET developer based in Berkshire, UK. I'm an honorary member of the core collaborators team. And non-work me, I spend a lot of time with my little girl. I spend a lot of time reading, and I'm also learning Carnatic music, which is a stream of Indian classical music for the last 3 years. And that's my Twitter handle, should you wish to connect with me. So let's talk about Umbraco Hardcore first. Um, there's been some fantastic talks before me at Codegarden CG 2021, but repeating some of the things again, uh, it is a headless SaaS offering of the Umbraco CMS. Headless because there's no head, that is the website aspect of the CMS, but the focus is on the storing and delivery of content. So you can have the same content powering a website to a knowledge base to an IoT device. So it gives an omni-channel omni-channel experience to your customers, but still something which is cohesive and seamless across the branding of the across your brand across the various different platforms. You can create a hardcore project using the Umbraco Cloud Portal. Every hardcore project comes with a REST API for content delivery as well as content management. The GraphQL endpoint, which we are going to focus today, I think, comes along with the starter plan and about that. And it can be used to query content, both published as well as draft. Now, talking about GraphQL, what is GraphQL? At its simplest definition, it's asking for specific types and specific fields on the specific types. It comes across as one of the cool kids on the block when we talk about APIs, and GraphQL is essentially a query language for your API. And the query language helps you ask for specific fields on specific types. I cannot say if I have a talk type or a speaker type, get me everything about that particular entity. I have to be specific about what I want. And the main advantage and the reason why GraphQL was invented in first place is to cater in for exact fetching. If you think of the traditional REST model API, what you would be doing is overfetching. Say, for example, you would want just the talk title or a talk description. You would be fetching the entire information about the talk, using up the talk title, discarding the rest. And it goes hand in hand with underfetching. You might want the talk as well as the speaker information, but you don't have any method of getting both in one go. So you end up calling multiple APIs to get more information, using a part of it and discarding the rest. It's not very green, and that's exactly why GraphQL was invented in first place. With GraphQL, the consuming apps are in control of asking what they want. So they get the opportunity of asking what they want, and what they get in return is exactly what they ask for, nothing more. And GraphQL is quite smart that way. So the client apps are in control. And if you see my example query that I have on my screen, I'm asking for a course of an ID 1045. I cannot say, hey, fetch everything about the course for me. Instead, I have to be specific about what I want, say ID, credits, and so on. I can ask even for related information. So the student enrollment information about a course must be or might be in a separate different table, or it might be another REST endpoint that could be fetching it for you. But GraphQL can kind of put it all together and send it back to you. And what I get back is a JSON response, which is a mirror image of my query. So that means my response is more predictable. I, as a consuming developer, I don't need to go and ask the server-side developer, hey, what the response is going to be like, because I can predict from my query what the response is going to be like. Talking about Blazor, I'm sure you might have watched Scott Hunter's talk yesterday, and you might have come across how Blazor is important to Microsoft at this point of time. It's a single page application framework from Microsoft. And call me full stack because I can create rich interactive UI with C# now. Unlike Silverlight, where you have had to have plugins installed to your browser to run the code within your browser, Blazor makes use of native browser functionality to run C# on your browser. There are two hosting models: the WebAssembly model, which is considered the primary hosting model, and the Blazor server. With WebAssembly, all the dependencies, all the DLLs are downloaded to your client machine, and then it runs within the JavaScript security sandbox. With the Blazor server hosting model, it is more traditional hosting model where the app resides on the server and the client communicates to the server using a SignalR connection. There's PWA and there's upcoming Blazor desktop apps with MAUI, but more on that later on or probably in another talk. So let's see what I've got for you today. I've got this little WebAssembly-based app where I'm displaying the information about all the talks at Codegarden this year. I can say view the details and I can see what the details about what the talk is all about, who the speaker is, and what the bio of a speaker essentially. And that's my little app, and this is my hardcore instance. So I've got all my content here. So all the talks and all the speakers are listed here as content nodes. And in my document type, I've got a set of document types, one for the Codegarden home with some standard properties, one for the talk, again with some standard properties. I've got a speaker picker here, which is a multi-node tree picker, which helps me pick content nodes of the type speaker, again, which is a content type, with some standard Umbraco property editors. Now let's go into the GraphQL endpoint in Hardcore in specific. The endpoint is available at GraphQL and it accepts post requests. So with REST APIs, what you would do is get data over a GET request, but with any GraphQL endpoint, it's fair to say that it accepts post requests. You can use Postman to test your GraphQL requests, because now Postman supports native GraphQL queries as request bodies. You can pass in GraphQL queries as well as variables alongside it. There's all sort of things in Postman, like you can download the schema and even validate your query against that schema. So Postman can be used. And when we have an API, it's important to talk about API access. And let's have a look at that. The GraphQL API is public by default, but it can be made protected in the back office. But every post request to your GraphQL endpoint, be it a public API or a protected API, it needs a header called the ump project alias. And the value of the header must be the alias of your project in the cloud portal. If you wish to make your endpoint protected, then obviously you need to turn the protected toggle on in the back office, and the user must be set up in the back office with relevant permissions. And from there on, you can set up an API key for your user, and that API key must also be passed alongside the ump project alias when you make the post request. When we talk about GraphQL endpoints, it's very important to talk about schemas because schema is the heart and soul of any GraphQL endpoint. GraphQL is a specification, a blueprint, and various different programming languages and frameworks have implementations of GraphQL, and they try to conform to that specification. And all these implementations let you generate the schema in one way or other. GraphQL schema has types at its heart. So the first one is object types, which is essentially a representation of objects, what you can get information about. Say you have entities like talks, speakers, so all of them are object types. And then you have query type, which is the root operation type to read the data. So the main thing to understand here is that both of these are types. And when it comes to hardcore, the object types relate to content types, because what we are doing from hardcore is we are asking for content of specific content types from hardcore. So our object types take the meaning of content types in hardcore. And with regards to query types, is the root query operation that we have in hardcore. Any GraphQL schema that you take, it will have at the least object type and query type. We have other GraphQL types called mutation and subscription. That's not available as a part of Hardcore because the endpoint in Hardcore is all about reading the data, not changing it. So these makes up the types in Hardcore. And types are made of fields. So when we think about object types, the fields correspond to the content type properties. Every field has a name. And with regards to Hardcore, it's the property alias which takes the shape of the name of the field. Every field has a scalar or a complex type which it resolves to. This is the concrete data type that it resolves to. And in Hardcore, this is driven by the property editors of each of those properties. And there's also something called resolvers, which is more of a server-side concept. And this is handled by Hardcore for us. And resolvers tell a field how to resolve into concrete data. This is completely handled by the infrastructure for us. We don't need to worry about it. So, and as I said, fields correspond to content type properties. Now, how does the schema get generated in Hardcore? Every time a content type or data type is saved, the schema is regenerated. If you have a content type, say talk, in your Hardcore instance, a GraphQL type or an object type is generated for it, and the name of the GraphQL type will be the name, the content type alias of the content type in Pascal case. There are certain conventions or rules that are followed as well. GraphQL also has the concept of interfaces, like any other programming language might have. So if you have an interface, you need to implement the interface for a type which uses the interface. So in Umbraco world, we have the concept of compositions. And if you are using a composition in your content type, a composition takes the shape of an interface, and content types which uses the composition will implement the interface. All other content types will implement the content interface or the media interface. And if you have element types, they implement the element interface. So that is about the object types. So when I spoke about schema, I told you that query types are also types in GraphQL. So regardless of how many document types you have in your Hardcore instance, you will have two fields in your root query type, which is all content and content. All content helps you query for all the content in your Hardcore instance, irrespective of the document type or the content type underneath it. And content field helps you get a particular content by its ID or URL. And for every content type that you have in your Hardcore instance, two fields are generated in the query type again. So one to query a particular content type by its ID or URL, and the other to query all content of a particular type in a Hardcore instance. So for example, if I have a talk content type, it will generate a GraphQL type, which is the object type. It will also generate a talk and all talk field in the query type for querying content of the particular type. So let's have a look at the Hardcore instance once again and have a look at the GraphQL playground. So I think the most important change when it comes to Hardcore instance is the headless section. This is where you can make your API protected if you want. And from there on, if you need to create a user and set up API keys and pass that alongside your post requests. There's also something called the GraphQL Playground, which is available and kind of integrated into the back office. So GraphQL Playground is a browser-based IDE to test your GraphQL queries. It can do a lot more than just testing your GraphQL queries. But if you're familiar with Swagger for web APIs, you would come across this as something familiar too. GraphQL endpoints are always introspective, which means you can query a GraphQL endpoint to understand more about itself. So these browser-based IDEs make use of that functionality to come up with docs about your endpoint, which means if you have a GraphQL endpoint, have a GraphQL playground integrated into the endpoint, and it will generate all the documentation from the code for you. So what you see here is a list of the fields in my root query type. So I've been playing alongside a lot of different things. So let me show you the all talk type, which returns a talk connection. So I can understand what fields are available, what options are available for me for filtering and sorting, what the field returns, and what the arguments are as well. It also generates the schema for me. I can see the schema. So this is this entire schema of my GraphQL endpoint in Hardcore generated in schema definition language, which is like a language agnostic way to talk about GraphQL schemas. So that's GraphQL Playground. Now let's have a look at some queries. So let's try and get all the talks from my GraphQL instance. So I've got this query here. I started with a query keyword, which tells it that I'm asking for a query. I'm trying to read data. The next thing we need is an arbitrary name for my operation, say get talks. Then I'm using the all talk field in the query to get me all the talks. Whenever you have a field generated in this in the root query type, it also generates fields for ordering the data. That is done by default for me. And I think the order fields are available for the simple property editors like Boolean, date time, text string, etc. So the talk date and time that I have is a date time type, and ordering is available for me by default. So I am trying to order it in the ascending order of talk date and time. The all talk field has a items field, which is a convenience field to get me all the items in that particular connection. And what it returns is a list of talk, as you see here. So something in square brackets means it's a list type in GraphQL, and it returns me a list of talks. And for each of the talks, I can ask for headline, description, the stage where the talk is on, and the URL. And that is me running my query, and I can get all the information. And when I try to read that using a client tool, what I'm trying to do, the data is what comes in between this data field, starting with the all talk, and I can kind of deserialize that and use that in my app to present. Now, what if you want to get a particular talk using a URL, which again we'll be looking at from the Blazor app, but let's have a look at the query for it. So I start with a query and an operation, an arbitrary name for my operation. Uh, GraphQL supports arguments, and I can kind of generalize it using variables as well if I want to pass different values. And this is how I specify variables in GraphQL using a $sign. I need to give it a type, and this type must match the type of the original argument, otherwise it's going to throw up errors. Then I'm going to use the talk field on my root query type, and I am setting my variable value to the argument. And then I can ask for the headline, description, stage, the fields that I want basically. When it gets to the speaker, I also want the speaker information, but natively the query returns a list of content because every piece of content in Hardcore implements the content interface. So I need to cast it to the actual type because on the content type, we don't have the fields that you see here, like the speaker name or the speaker title. So I'm using something called inline fragmenting, which helps me cast that content into the original type, which is speaker, and then I can use the fields on it to query it. And then I need to pass my variable as a separate dictionary, which is what I'm doing here. And this URL is what you see for the content in the info content app itself. Now running this, it gets me back the information about my talk. And as you can see, I'm only getting back what I asked for, nothing more or nothing less. So that is about the query that we are going to have a look at in the Blazor app. Talking about the Blazor app, I have a WebAssembly Blazor app setup based on .NET 5. We also need a GraphQL client to communicate to the GraphQL endpoint. I'm using something called Strawberry Shake. I love the name. You can by all means use the HTTP client factory, or there's a another .NET-based client called GraphQL for .NET client. You can use that as well. But I've used both of it before, so I'm trying to do something new here with Strawberry Shake. The advantage of Strawberry Shake is that it lets me generate a C# client, a strongly typed C# client from the GraphQL queries that I input. And what it does is it creates a client for me here. And on the client, there are properties. And these properties corresponds to the GraphQL queries that I have in my application. So I've got a get home query. I've got a get talks query for all my talks. I've got a get talk for each of the talk. What Strawberry Shake does is for each of the queries that I have here, it generates an operation service, and that is available on my client. So it's all strongly typed. And the data that I get back, which I showed you before, is usually what you see inside the data field. All that is deserialized for me as well. I don't need to write 1,000 POCOs to make sure that it is all deserialized property. The name is right. There is no code. There's no code redundancy either. So it makes it all smart for me. And each operation type also has an execute async method, which does the job of reaching out to the endpoint and then getting the data back for me. There's a fair bit of setup involved in this, and I've captured all that into this little bit.ly link here. Feel free to give it a read as well. And talking about the setup, the actual Blazor app itself, I'm using some basic concepts in Blazor to come up with this app. The first being components. Components are building blocks of Blazor apps, and they are files with .razor extension. When components are compiled, they become C# partial class with the same name as the component. So if I have a component, say, for example, that wasn't very nice. So if I have a talk details component here, the component, when it compiles, it gives rise to a C# class called the say talk details. And if I want to include C# code in my component, I can use that in a page directive, or I can put it in a separate partial class of the same name, or I can even inherit a class from component base and do it that way. There is opportunity for us to create shared components. Shared components won't be routed. In this case, this is a routed component and they can be reached via a URL, but you can create shared components like the one I've got here for talks. This is not a routed component, and if you want to use this particular component from any other component, the name of the component becomes the HTML tag. So if I want to use the talks.razor component elsewhere, I have to use the name of the component as the HTML tag. So you have the opportunity to share components as well. You can come up with, you get library of components. You can create Razor component libraries, all of which are normal in the Blazor world, I guess. The next topic I want to talk about in Blazor is the concept of routing. So this particular component that you see has a page directive. So page directive is an indicator to Blazor that this particular component is routed. And this specifies the route template for this particular router, so particular component. So when such components are compiled, it attaches a route attribute to the generated partial class and gives it a route template. When a user asks for a particular URL, the router tries to find a match between the incoming URL and the route templates it's got the awareness of. And then if it finds a match, it returns that particular component. Route templates can have route parameters as well. So in my case, talk title is a parameter, a route parameter, and this is how you specify it, a string name inside the curly braces. And to consume that in my code, I need to specify a public property of the same name as the route parameter. And I also need to indicate that it is a parameter using the parameter attribute. So this automatically matches up the value that comes in the URL to this particular property, and then I can keep using that in my code. So let's see what is happening in my Blazor app. In my talks little component called talks. This is where I am going to display all the list of talks. So I already have this client generated here by Strawberry Shake. I can inject that because the client that is generated by Strawberry Shake can be injected to your DI container. And then I am making use of this lifecycle event in Blazor called onInitialized async. So this is the second lifecycle method which runs for any component in Blazor. And this method runs for the first time when a component is initialized. And it's usually considered the best place to initialize your data in a Blazor component. So I can use of the CG demo client. So the query corresponding to this particular component here is get talks, which helps me get all the talks. And I'm using a feature or a concept called fragmenting in GraphQL, which is like creating little pieces of code, which I can then kind of reuse. So in my fragment called talk info, I am asking for ID, headline, description, stage, talk date and time, and URL of the talk. And I can use that in my GraphQL query like so. This indicates that there's a fragment and I'm trying to use that fragment in my code. So this would generate an operation service property called getTalks for me. So I can use the getTalks property on the CG demo client, and then that operation service has got an execute async method, which does the job of reaching out to the service, getting me back the response. The response.data is what corresponds to the data that you see here in the back office. What you see here, sorry, the wrong query. What you see here. And Strawberry Shake does the work of deserializing all that information for me into POCOs. So I can use allTalk.items, which kind of matches up to my query. And then I can assign it to a private property, loop through the various talks and display them. As you can see, I'm using the talk URL from my hardcore instance itself as the navigation link so that it sets the tone for me straight away. So which means when I get to the talk details page, I've got a URL which is similar or which is as good as the URL in my hardcore instance. So I can manipulate the code very easily to send the query in again to get the details out. So that is my talk list that you can see here. And when I go into the details page, what happens is I've already got this as a route template for me. And this part of the URL becomes the route parameter. So what I can then do is in my code, I've already got the talk title as a parameter, which means I've got the full URL of my hardcore node from my app itself. Because it's a parameter that comes in, I cannot use the onInitialized async method to initialize my data because Blazor being a SPA framework, the onInitialize method runs only for the first time a component is initialized. So if you want to do something every time a parameter changes, we need to make use of this onParameter set async method. So and in that method, I can again use the CG demo client, use the get talk method, which is the operation service that gets created or generated for my query here, which correspond to getting the data about a particular talk. And again, I can make use of the execute async method. This time, I'm also passing in the URL. And the URL is formed by concatenating a forward slash with the URL of the navigation manager. The navigation manager is again an object or an interface that's injected here, which helps me get the information about the navigation around the Blazor app. It helps me build the URL. I can pass it on to my GraphQL endpoint, get the data back, and display that. And that is what happens here. So I can see all the information. So that's my little introduction to Blazor and GraphQL and Umbraco Hardcore for you. So all the resources for my talk today are collated into this bit.ly URL. I'll be at the Unconference later on as well. Thank you very much for having me at Codegarden 2021.